Have you ever looked up at the night sky and felt like you were missing something? Like there's something out there, something massive and invisible, something that's been there all along, but you just can't see it. That's not a metaphor. That's not poetry. That's physics. Because right now, at this very moment, you are surrounded by something that makes up most of the universe, something that holds galaxies together, something that shapes the cosmos, something that scientists have been hunting for decades, something that passes through your body every single second without leaving a trace, and we have no idea what it is. We call it dark matter, but that name is just a placeholder, a label for our ignorance, a way of saying we don't know what this is, but it's definitely there. Imagine standing alone under a perfectly dark sky, far from any city lights. The stars are all around you. The Milky Way stretches across the heavens. It's beautiful. It's awe-inspiring. It's everything you've ever known about the universe. But what if I told you that everything you see, every star, every planet, every galaxy, makes up only about 5% of what's actually there? The other 95%, invisible, unknown, unseen. And of that 95%, about 27% is something we call dark matter, a substance so elusive, so mysterious, that we've never seen it, never touched it, never detected it directly. And yet we know it's there. We can measure its effects. We can map its distribution. We can see how it bends light and shapes galaxies. But we still don't know what it is. So what is dark matter? Really, not the name, not the label, the actual thing. What is it? Where did it come from? Why does it exist? And why can't we find it? Let me take you on a journey into the invisible universe, a journey into the heart of the greatest mystery in modern science, a journey to understand the stuff that makes up most of everything, the discovery that changed everything. Our story begins in the 1930s, in a time when the universe seemed simpler. Astronomers thought they understood the cosmos. They thought they knew what it was made of. They thought the stars and gas and dust were all that existed. But a Swiss astronomer named Fritz Zwicky was about to shatter that illusion. He was studying a cluster of galaxies called the Coma Cluster. He measured how fast the galaxies were moving, and he found something that made no sense. The galaxies were moving too fast, way too fast. According to everything we knew about gravity, they should have flown off into space like rocks from a slingshot. The cluster should have torn itself apart. But it didn't. Something was holding it together, something invisible, something that defied explanation. Zwicky calculated that there had to be about 400 times more mass in the cluster than what he could see. The visible stars and gas simply weren't enough to hold the cluster together. There had to be something else, something hidden, something dark. He called it dark matter, and nobody believed him. For decades, his discovery was ignored. Scientists thought he made a mistake. They thought his measurements were off. They thought he was just being dramatic. It was too strange, too unbelievable, too much like science fiction. But the universe doesn't care what we believe. Then, in the 1970s, a young astronomer named Vera Rubin changed everything. She was measuring how fast stars orbit the center of galaxies. It was supposed to be a routine measurement, confirm what we already knew. But something wasn't right. According to physics, stars on the outer edges should move slower than stars near the center. That's basic gravity. Planets farther from the sun move slower. It's the law. It's what Newton taught us. It's what Kepler observed. It's one of the most fundamental principles in all of physics. But Rubin found the opposite. The stars on the outer edges of galaxies were moving just as fast as the stars near the center. They were zipping around at speed that should have flung them into intergalactic space. But they weren't flying away. Something was holding them there. Something invisible. Something powerful. Rubin's discovery was the smoking gun. Dark matter was real. Every galaxy we see is surrounded by an invisible cloud of mass that keeps it from flying apart. It's like a cosmic spider web threading through the universe, holding everything together. Without this invisible substance, galaxies would literally disintegrate. The stars would fly off into the void. The beautiful spiral structures we see in the night sky would vanish. The universe would be a very different place, a lonely place, a place where everything falls apart. But what was this invisible stuff? What was holding the galaxies together? Nobody knew. The hunt for the invisible, Scientists went looking for dark matter in every way they could think of. They looked for failed stars called brown dwarfs. These are objects too small to ignite nuclear fusion, but large enough to have significant mass. They looked for black holes left over from the early universe. They looked for clouds of gas too cold to see with our telescopes. They even looked for hypothetical particles that only interact through gravity, particles that were predicted by theories but never observed. They found nothing. Here's the thing about this hidden component. It doesn't emit light. It doesn't absorb light. It doesn't reflect light. It's completely invisible to every instrument we've ever built, from the smallest optical telescopes to the most powerful radio arrays. The only way we know it exists is through its gravitational effects. It bends light as it passes by, a phenomenon called gravitational lensing. When we look at distant galaxies, we see their light being bent by something in between, something massive, something invisible. The amount of bending tells us how much mass is there, and the mass is always more than what we can see. It shapes the structure of the universe, creating the cosmic web of galaxies and voids that we observe. When we map the distribution of galaxies, we see that they're not randomly scattered. They are arranged in a vast cosmic web with filaments and clusters and voids. And this structure couldn't have formed without dark matter. Ordinary matter wasn't enough. It needed the gravitational pull of this unseen structure to clump together and form the structures we see today. It influences the formation of galaxies, providing the gravitational seeds that allow them to grow. Without the invisible framework, the universe would look completely different. There would be fewer galaxies. They would be smaller. The cosmos would be a far emptier place. But beyond that, we don't know. Here's the wildest part. Dark matter passes right through normal matter like it's not even there. Right now, billions of particles of this invisible substance are streaming through your body. They're passing through the walls of your house, through the floor, through your skin, through your organs, and you can't feel them because they don't interact with the atoms in your body. They are like ghosts, completely invisible, completely untouchable, and all around us. Imagine standing alone under a perfectly dark sky. Every second, trillions of invisible particles pass through your body without leaving a trace. They don't stop. They don't collide. They simply continue their silent journey across the universe. They've been traveling for billions of years. They've crossed galaxies. They've passed through stars. And now they're passing through you. If you could see dark matter, the night sky would look completely different. It wouldn't be a dark void with tiny points of light. It would be a glowing, swirling sea of invisible mass, threading through every galaxy, stretching across the cosmos. It would be breathtaking. It would be terrifying. It would be everywhere. This hidden component outnumbers normal matter by about 5 to 1. It makes up about 27% of the universe. We know it's there. We can measure its effects. We can map its distribution across the cosmos. We can see how it bends light and shapes galaxies. But we can't see it. We can't touch it. We can't explain it. The candidates. So what could dark matter be? Scientists have proposed many candidates. Each one is fascinating. Each one is strange. Each one pushes the boundaries of our understanding. But here's where things become even stranger. Let's start with the most popular candidate, the WIMP. That stands for Weakly Interacting Massive Particle. WIMP are hypothetical particles that interact through gravity and the weak nuclear force, but not through electromagnetism or the strong nuclear force. They would be heavy, they would be stable, they would be everywhere, and they would pass through normal matter like it wasn't there. WIMP are attractive because they naturally arise from certain theories in particle physics. Supersymmetry, for example, predicts the existence of many new particles, some of which could be WIMP. If supersymmetry is correct, WIMP should exist. And if WIMP exists, they could be dark matter. But here's the problem. We've been looking for WIMP for decades. We've built detectors deep underground, waiting for a WIMP to bump into an atomic nucleus. The detectors are buried miles beneath the Earth's surface, shielded from the cosmic radiation that would otherwise drown out the signal. They are incredibly sensitive. They can detect the faintest whisper of a particle interaction, and they've been running for years. So far, they've found nothing, not a single WIMP. But that doesn't mean they're not there. It just means they are harder to find than we thought, or they don't exist, or our theories are wrong. Every experiment has brought us closer, and yet the mystery remains. Now let's talk about the action. Actions are hypothetical particles that are incredibly light and incredibly weakly interacting. They were originally proposed to solve a problem in quantum chromodynamics, the theory that describes the strong nuclear force. But they also happen to be excellent candidates for dark matter. Actions would be very different from WIMP. They would be light. They would be cold. They would behave more like a wave than a particle. And they would be incredibly difficult to detect. But we're looking. We're building experiments to search for action. We're hoping to find them. Perhaps dark matter is made of sterile neutrinos. These are hypothetical particles that interact even more weakly than normal neutrinos. They would be heavy. They would be stable. They would be dark matter. They would be almost impossible to detect, but they might exist, and they might be the answer. There's another possibility scientists can't ignore. What if dark matter is made of primordial black holes? These are black holes that might have formed in the first moments after the Big Bang. The universe was incredibly dense. Some regions might have collapsed directly into black holes. These black holes could be any size. They could be as small as a proton. They could be as large as a planet. They could be everywhere. They could be passing through your body right now. We don't know if they exist, but we're looking. And then there's the idea that dark matter might be made of macroscopic objects, planets, brown dwarfs, black holes, anything that's massive and dark. But we've looked for these objects too, and we haven't found enough of them to explain dark matter. So we have candidates, we have theories, but we don't have answers. Dark matter remains a mystery. The evidence, but how do we know dark matter is real? How do we know it's not just a mistake? How do we know we're not missing something? The evidence is overwhelming. It comes from multiple independent observations, and they all point to the same conclusion. Dark matter is real. First, there's the rotation curves of galaxies. This is what Vera Rubin discovered. Stars on the outer edges of galaxies move too fast. They should fly off, but they don't. Something is holding them there. This is the most direct evidence for dark matter. Second, there's gravitational lensing. Light bends around massive objects. When we look at distant galaxies, we see their light being bent by something in between. Something massive, something invisible. The amount of bending tells us how much mass is there, and the mass is always more than what we can see. Third, there's the cosmic microwave background. This is the afterglow of the Big Bang. It's a faint glow of radiation that fills the entire universe. When we measure its fluctuation, we can determine the composition of the universe. And the data shows that dark matter makes up about 27% of everything. Fourth, there's the formation of structure. The universe has a cosmic web of galaxies and voids. This structure couldn't have formed without dark matter. Ordinary matter wasn't enough. It needed the gravitational pull of dark matter to clump together and form galaxies. Fifth, there's the bullet cluster. This is a cluster of galaxies that collided with another cluster. The ordinary matter, the gas and dust, slowed down and stayed in the middle. But the dark matter passed right through. It didn't collide. It didn't slow down. It just kept going. This is direct evidence that dark matter exists and that it's different from ordinary matter. So we have evidence, we have measurements, we have observations, but we still don't have answers. The missing piece. Now let's think about what this all means. What does it mean to be surrounded by something we can't see? What does it mean to live in a universe that is mostly unknown? What does it mean to be part of a cosmos that is hiding its secrets? It means we are not the center of the universe. It means we are not the most important thing in existence. It means there are things out there that we don't understand. And that's humbling, but it's also exciting because it means the best discoveries are still out there. The biggest breakthroughs are yet to come. The greatest mysteries are waiting for someone to solve them. Dark matter is the missing piece of the puzzle. It's the thing that doesn't fit. It's the anomaly that challenges our understanding. And anomalies are where new discoveries are made. They are where science advances. They are where revolutions begin. Every time we've found something that didn't fit our theories, it's led to a breakthrough. The orbit of Mercury didn't fit Newton's laws. That led to general relativity. The expansion of the universe didn't fit our expectation. That led to the Big Bang Theory. Dark matter doesn't fit our models, and that means we're on the brink of something new. Could dark matter be an entirely new form of matter, something we've never seen before, something that doesn't fit into our existing categories, something that challenges our understanding of physics itself? Could it be that it's been passing through Earth since the beginning of time, and we're only just starting to realize it's there? Could discovering it change every law of physics? Could it be the key to understanding the fundamental nature of reality, the mind-blowing possibilities? Let's go deeper. Let's explore the mind-blowing possibilities. The ideas that will make you question everything you thought you knew about the universe. Perhaps dark matter is not made of particles at all. Perhaps it's something else entirely, something we've never even considered, something that challenges our understanding of physics itself. There's a theory that dark matter might be connected to parallel universes. Some scientists suggest that dark matter might be leaking into our universe from other dimensions. It might be a remnant of the multiverse, a sign that there are other universes out there, hidden from our view. Another possibility scientists can't ignore is that dark matter is not matter at all. It could be a modification of gravity. What if our understanding of gravity is incomplete? What if there's a missing piece in Einstein's equation? What if dark matter is just a sign that we need a new theory of gravity? Perhaps dark matter is the key to understanding the fundamental nature of reality. Maybe it's the thing that connects quantum mechanics and general relativity. Maybe it's the bridge between the very small and the very large. Could it be that Einstein was incomplete? What if his theory of general relativity, one of the most successful theories in the history of physics, is missing something? What if dark matter is the sign that we need to revise our understanding of gravity? There's also the possibility of hidden dimension. What if the universe has more than 3 spatial dimensions? What if dark matter is leaking from these dimensions? What if it's a sign that there's more to reality than we can see? Some scientists even consider the idea that dark matter is the ghost of another universe. What if it's the remnant of a previous universe? What if it's the echo of the Big Bang? What if it's a message from the beginning of time? These are not just science fiction. These are ideas that scientists are actually considering. They are ideas that are being explored in research papers and conferences. They are ideas that challenge our understanding of reality. If dark matter suddenly became visible, imagine if, for just 1 second, dark matter suddenly became visible. What would we see? Every galaxy would light up with enormous invisible halos. Vast rivers of unseen matter would stretch across the universe, connecting galaxies like glowing threads in a cosmic web. The empty darkness between the stars would no longer seem empty at all. You would see that the universe is not a collection of isolated islands of stars. It's a vast, interconnected web of matter. Galaxies are not alone. They are connected by massive filaments of dark matter. They are part of a cosmic ecosystem. They are part of something much larger than themselves. You would see that the space between galaxies is not empty. It's filled with this invisible, glowing substance. It's everywhere. It's in every corner of the cosmos. It's the scaffolding of the universe, the skeleton on which everything is built. You would see that dark matter is not just a curiosity. It's the dominant force in the universe. It shapes the cosmos. It holds everything together. Without it, galaxies as we know them may never have form, and our universe would look dramatically different. And you would realize that we are not separate from the universe. We are part of it. We are connected to everything else. We are part of the cosmic web. We are part of the dark matter. We are part of the universe itself. This is the reality we live in. We just can't see it. The future. So what does the future hold? What will we find? What will we discover? The next decade will be transformative. New experiments are coming. New telescopes are being built. New theories are being developed. We're on the brink of a revolution. The Large Hadron Collider is searching for new particles. It's looking for supersymmetry. It's looking for WIMP. It's looking for anything that might be dark matter. So far, it hasn't found anything, but it's still searching. It's still pushing the boundaries. Deep underground detectors are looking for dark matter. They're filled with liquid xenon. They're waiting for a WIMP to bump into an atomic nucleus. They are incredibly sensitive. They can detect the faintest signal, and they've been running for years. So far, they've found nothing, but they are still looking. Space telescopes are mapping the distribution of dark matter. They are measuring gravitational lensing. They are tracking the formation of structure. They are studying the cosmic microwave background. They are providing more data, more evidence, more clues, and new experiments are being proposed. Action detectors, neutrino telescopes, quantum sensors. Each one is designed to probe a different aspect of dark matter. Each one is a different way of looking at the same mystery. Imagine if we find WIMP. It would confirm the leading theory. It would be a triumph of particle physics. It would answer the question of what dark matter is. But it would also raise new questions. What are WIMPs? Where did they come from? Why do they exist? Perhaps the answer is axions. It would be even more revolutionary. It would confirm a theory that was proposed to solve a different problem. It would show that the universe is even stranger than we thought. Another possibility is sterile neutrinos. It would open up a whole new field of study. It would show that neutrinos are not the end of the story. There are more particles out there, more mysteries to solve. And then there's the idea of primordial black holes. It would change our understanding of the early universe. It would show that the Big Bang was even more violent than we thought. It would reveal a new population of objects in the cosmos. But what if every experiment fails? What if all our detectors come up empty? It would mean that our theories are wrong. It would mean that dark matter is something else entirely, something we haven't even considered, something that will revolutionize physics. One day, we will find it. We will discover what dark matter is. We will understand its nature. We will unlock its secrets. And when we do, it will change everything. It will rewrite the textbooks. It will revolutionize our understanding of the universe. It will be one of the greatest discoveries in human history. The humbling truth. But until then, we have to live with the mystery. We have to accept that we don't know everything. We have to be humble about our ignorance. The universe is vast. It's full of mysteries, full of wonders, full of things we don't understand. And that's okay, because the journey of discovery is what makes life meaningful. The journey of exploration is what makes us human. The journey of understanding is what makes us whole. Dark matter is the greatest mystery in modern science. It's the thing we can't see, the thing we can't explain, the thing that makes up most of the universe. And it's the thing that reminds us how much we still have to learn. The next time you look up at the night sky, remember this: you're not just looking at stars. You're looking at a universe that is mostly invisible, a universe that is mostly dark, a universe that is mostly unknown. And that's not a failure. That's an invitation to keep exploring, to keep asking questions, to keep pushing the boundaries of what we know, because the universe is still full of secrets, and we are the ones who get to discover them. Dark matter is out there. It's all around us. It's passing through us right now. And one day, we will understand what it is. We will unlock its secrets. We will solve the greatest mystery in modern science. Maybe one day, a child looking up at the stars will grow up to solve this mystery. Maybe the answer already exists, waiting quietly in data we've already collected. Or maybe the universe still has surprises we haven't even imagined. That's the beauty of it. The unknown, the mystery, the possibility. Until then, we have the joy of wondering, the thrill of not knowing, the privilege of being alive at a time when the biggest questions are still unanswered. And that, I think, is the most beautiful thing of all.